good day, guys. This is looking at a question on the limits. That's limits as x approaches 2 of x squared plus 16 over absolute value of x minus 3. Now, to solve this particular problem, you need to know, you need to substitute the 2 into this. Now, because we are dealing with absolute value, so we are dealing with absolute value of x minus 3, which means that we are going to deal with positive and negative numbers here. So let's start with the positive form. So we have this 2 minus 3, which will give us negative 1. Then with the negative form, we have negative of 2 minus 3, which will be equal to 1. Now we are going to substitute. So for our first evaluation, we are going to substitute our 2 minus 3 as negative 1 for the absolute value of x minus 3, and substituting 2 into the numerator. Okay, so now, so for our limit of x approaches 2, we can get now 2 what squared plus 16 all over. Now we are substituting negative 1, so all over negative 1. So our limit as x approaches 2 will be 2 squared is 4, so 4 plus 16 over negative 1. So our limit as x approaches 2 will be 20 over negative 1, and this, so limit as x approaches 2, that's 20 over negative 1, which is equal to negative 20. So now for our limit as x approaches 2 using the positive form, we will just, so our limit as x approaches 2 using the positive form, we just make our limit as x approaches 2, make this value a positive value. So for the other one, we have limit as x approaches 2 of that expression, so of our expression will be equal to 20, right? Because if we substitute the positive part of this absolute value of x minus 3, we get 1. Now 2 squared before plus 16 should be 20. Now 20 over 1 will give us 20, which we've written as 20. So the limit of x approaches 2 of our expression, which is x squared plus 16 over absolute value of x minus 3, will be equal to negative 20 for our negative value, and for our positive value we are going to get 20. Now we are going to see if these are actually the solutions for our particular problem. Now there's a certain law according to the squeeze law. Now this law makes us understand that if you have 3 functions, that is f of x, g of x, and h of x, if you have these 3 functions, then supposing if f of x is less than or equal to g of x, it's also less than or equal to h of x, then our g of x will be equal to our f of x, which can be equal to our h of x in terms of the values that will be gotten. So in terms of the value that will be what gotten, so our g of x can be equal to f of x, can be equal to our h of x. Now, so we are taking it that this particular expression, limit as x approaches 2 of x squared plus 16 all over our x minus 3, we are taking it that using the positive value, it is our f of x. So limit as x approaches 2 of x squared, so 2 plus the positive 2, x with the positive for the absolute value, x squared plus 16 over absolute value of x minus 3, absolute value of x minus 3. We are taking it that this is our f of x. We are taking it that our g of x will be limit as x approaches 2 with the negative value of our absolute value to be x squared plus 16 over the x minus 3. So according to the squeeze theorem or our squeeze law, so according to the squeeze theorem or squeeze law, it states that what f of x, so g of x can only exist if f of x is less than or equal to g of x, is less than or equal to h of x. So if f of x is equal to h of x, then g of x is equal to f of x is equal to h of x. So now we had what for the substituting the positive value, taking the positive value of the absolute value, we had negative 1, which we had negative 20, and the other one we had what, we had 20. Okay, so if we are substituting the negative 20 and the 20, so our f of x is negative 20, the value of f of x is negative 20 when x is equal to 2. So f of 2 is equal to negative 20, and our g of 2 is equal to 20, right? Okay, so now we are substituting. So we can see that f of 2, which is equal to negative 20, is not equal to g of 2, which is equal to 20. So this means that according to the squeeze law, since our f of 2 is not equal to our g of 2, then our function h of 2 does not exist. So our function h of 2 does not exist. So our function h of 2 does not exist. Now, according to the squeeze law, it uses these functions, right? But you can also make your own assumption as putting h of x here and putting g of x here, right? So you can see that for me, we use this as what, f of x, and sorry, we use this as what, g of what, x. So this was our what, f of x, and this was our what, g of x. But according to the squeeze law, our h of x is here and our g of x is here. Why we used to compare? But for you using the squeeze law, you can substitute. You can even put g of x here and put h of x here and put f of x here. Either way, only if you are abiding by the law or the theorem. And now you can see that our f of 2 is negative 20 and our g of 2 is 20. Now these are not equal. Since these are not equal, which means that our function h of 2 does not what, exist. So this is the final answer. So hence h of 2 or our function f of x does not exist. Does not what, exist. So this is how you can solve this problem step by step.